The exact value of the 6 trig functions of the angle theta in each figure. So that's the first objective that you need to be able to fulfill, is you know the 6 trig functions, right? And let's just pick any one of these questions. I'll go with number 18 here. And all you need to do is you need to solve for the 3 sides of this triangle that we're looking at here, and then find the 6 trig functions for it. All right, so number 18, here is the root of 5, here is 2, and if we want to figure out what this side right here is, just use the Pythagorean theorem. So the smaller side, when you use the Pythagorean theorem, that's going to be the root of 5 squared, which is 5, minus 2 squared, which is 4. So 5 minus 4 is 1, and the square root of 1 is 1. So this right here is 1. So look at where the angle is. The angle is labeled as theta up here. So we're going to go ahead and find the sine of theta. The sine of theta would be opposite over hypotenuse, so 1 over root 5, and after rationalizing, that's going to become root 5 over 5. Next, the cosine of theta is going to be 2 over root 5, adjacent over hypotenuse, which after rationalizing becomes 2 root 5 over 5. Next is the tan of theta. The tan of theta is opposite over adjacent, which is simply 1/2. And then to find the other 3 trig ratios is the cosecant of theta, the secant of theta, and finally the cotan of theta, which if you remember, all you need to do is just take the unrationalized version of these and just flip them over. So 1 over root 5, when you flip that over, simply becomes a root 5. 2 over root 5, when it's flipped over, its reciprocal is root 5 over 2. And finally, cotan is going to be 2. All right? So that's the first objective. Let's move on to the next objective. This one's going to take us a little bit longer. Here, we're going to be finding the exact value of each expression. But for that, you need to learn a set of new identities. So here is basically what the cofunction identities say. They say that there is a relationship between finding the sine of an angle and finding the cosine of some other angle, the tan of an angle and the cotan of an angle, and then secant of an angle and a cosecant of an angle. All right, so let me give you a quick rundown of that, and then we're going to go ahead and try these identities that are in front of us. So here's a quick example for you. This is the famous 30, 60, 90. All right, so 30, 60, 90. 1, 2, the root of 3. I don't know if you've ever noticed this, right? It's not a coincidence. This is always going to work this way. If you find the sine of 30 degrees, you will notice that the sine of 30 degrees gives you 1 over root 2, right? And if you find the cosine of 30 degrees, it gives you adjacent over hypotenuse, which is root 3 over 2. And if you find the tan of 30 degrees, it'll give you opposite over adjacent, which is simply 1 over root 2. Similarly, if you find the cosecant of 30 degrees, the cosecant of 30 degrees is going to be 2. The secant of 30 degrees is going to be 2 over root 3, and then you can rationalize that if you wish. And finally, the cotan of 30 degrees is going to be root 2. That's right, root 3. I think I made a mistake here. This is 1 over root 3. Okay. Now, how do the cofunction identities work? All right, so when we say sine, and then we say the co of sine, there is a relationship, all right? Notice that if I had asked you for the cosine of 60 degrees, think about it. Find me the cosine of 60 degrees, and what do you get? All right, so you end up with 1/2. If you find the cosine of 60 degrees, you end up with 1/2. And that's what the cofunction identity says. It says that, did you know that finding the sine of 30, finding the sine of an angle, is the same thing as finding the cosine of 90 degrees minus that angle? All right, let me say that again. Let's suppose you were having to find the cosine of 30 degrees. All right, if you want to find the cosine of 30 degrees, that's root 3 over 2. Now just give it some thought. What if instead, what's 90 degrees minus 30 degrees? It's 60 degrees. What if you found the sine of 60 degrees? And again, you will find that the sine of 60 degrees is the same answer as the cosine of 30 degrees. One more time, these are called the cofunction identities. All right, now let's try, and so what that means is sine and cosine. All right, sine and cosine are cofunctions of one another. Whenever you want to find one of them, you can find the other at 90 degrees minus that angle, and you will get the same exact answer. So let's try another set of cofunctions, which is tan and cotan. All right, so tan. By the way, that is, if you've ever wondered how do they get these names, this is how they got those names. Okay, so cotan, because it is the cofunction of tangent. All right, so really quickly, if you were to find the cotan, all right, sorry, look at the tan of 30 degrees, right? So the tan of 30 degrees is 1 over root 3. Well, according to that second identity right there, if we had found the cotan of 60 degrees, the cotan of 60 degrees. Now let's give it some thought. If you wanted to find the cotan of 60 degrees, first off, you would find the tan of 60 and flip it over. So the tan of 60 degrees would have been root 3 over 1. I repeat, the tan of 60 would have been root 3 over 1. Now flip that over and it'll give you the cotan of 60, and the cotan of 60 would be 1 over root 3, which once again, according to the cofunction identity, we already knew that that was going to be the answer, because asking the question, what's the tan of 30, is the same thing as asking the question, what's the cotan of 60? All right? So this pattern is going to continue, right? So the cotan of 30 is therefore the same thing as the tan of 60. The cosecant of 30 is the same thing as asking the question, the secant of 60. And finally, finding the secant of 30 is the same thing as finding the cosecant of 60. So each one of these sets is actually going to give you the same answer regardless. All right, so it's a handy identity that we can use. And what I don't want you to get confused by is reciprocals, the reciprocal identities, the inverse of a function, right? So a reciprocal identity simply said that cotan theta is equal to 1 over the tan of theta. It said the sine of theta is equal to 1 over cosecant of theta. And it said the cosine of theta, I'm just giving you one version of them, okay, just randomly, 1 over the secant of theta. So initially these identities, they're like, you get confused with them, these new ones. You're like, wait a minute, are these the reciprocal? No, they're not the reciprocal. They're just saying if you wanted to find the sine of some angle, just find its right? Find its cosine, and you don't need to use that angle anymore. You can basically use 90 degrees minus theta. Okay, so it's an interesting way of going about it. It's not often used, these cofunction identities, but you do certainly need to know them though. All right, and again, don't get confused between inverse. To say if you have sine theta, what is its inverse? Its inverse is sine inverse of theta. All right, or more like sine inverse of the opposite side over the hypotenuse side which is equal to theta, right? So inverse means something else, reciprocal means something else, and cofunctions means something else, all right? Now what we're going to do is I'm going to show you guys a handful of interesting things that we can do because we have a handle of the cofunction identities. So let's take number 20 really quickly. Number 20 says that the tan of 12 degrees subtract the cotan of 78 degrees. And we've done a similar exercise in class where it says you can't touch a calculator to do it. Okay, otherwise, look, sitting at home, if you use the calculator, you have not understood the cofunction identity, right? So here's how this works. We know that the tan of 12 is the same thing as the cotan of 78 degrees. And the cotan of 78 degrees, technically, it is the same thing as the tan of 12, but we don't want to change that just yet, right? Because if we change it, then we're not going to come to an answer. And there you go. Now you have a cotan of 78 minus another cotan of 78, and so therefore the answer to this is going to be 0. All right? Let's take number 24. Let's try that. Number 24 says 1 plus the tan of 5 degrees squared minus the cosecant of 85 degrees squared. All right, so you're probably wondering, where are we going with this one? Well, let's see what happens. Recall that there is the Pythagorean identity, and the Pythagorean identity says that 1 plus the tan squared of theta is actually equal to what? It's actually equal to secant squared of theta. All right, so that's what I begin with. And because this piece over here says 1 plus tan squared 5 degrees, well, guess what I'm going to do? I'm going to change that 1 plus tan squared 5 degrees into secant squared 5 degrees. And again, how did I do it? I used the Pythagorean identity. All right. So now here's what the question looks like. It looks like secant squared of 5 degrees minus the cosecant squared of 85 degrees. Now this becomes relevant to the current lesson. What we'll do now is we'll say, look, the secant of 5 degrees is the same thing as the question of saying cosecant of 85 degrees. So you just do 90 minus that angle, and then you can use the co of that trig identity. So the secant can be changed into a cosecant as long as you do 90 minus 5 degrees. So it becomes cosecant squared 85 degrees, and this is also cosecant squared 85 degrees. Well, there you have it. That is also going to give you an answer of 0. All right. Again, it's easy to just plug this into a calculator, or to say, well, it's either a 0 or 1, but to know what that process is, that's why I'm going through this, and it's really important for you to know these. All right. By the way, before I move on to the next example, you could have, of course, taken the cosecant squared 85 and called it a secant squared of 5 degrees, right? And then that would have canceled these two out. But I just chose to take secant and change it into cosecant. All right. All right. Let's do number 28 here. Let's do number 28 here. Number 28 says that the secant of 35 degrees and the cosecant of 55 degrees. So what I'm going to do here is I'm going to change the secant of 35 degrees into the cosecant of 90 minus 35 degrees, which is actually 55 degrees. All right. So this one said cosecant 55 degrees, all right? So if you think about it, you'll have cosecant 55 degrees times cosecant 55 degrees, all right? Think about what that means. And on this side, you have tan of 35 degrees and the cotan of 55 degrees. Again, by that same logic, I'm going to change the tan of 35 degrees into the cotan, subtract sign, cotan of 55 degrees, so 90 minus that 35 is 55, and that allows me to change this from a tan to a cotan. So it'll be cotan 55 times cotan 55. Now where is this taking us? You basically have cosecant squared 55 degrees minus cotan squared 55 degrees. Once again, you'll have to consult your Pythagorean identities. This said 1 plus cotan squared theta is equal to cosecant squared theta. All right? And we know that if we wanted to take the cotan squared over to the right side, it's important to learn to shuffle these things around, then cosecant squared theta minus cotan squared theta is therefore equal to 1. Well, that's essentially what you're looking at. You're looking at cosecant squared 55 degrees minus cotan squared 55 degrees. Well, there you go. We have our answer. The answer to this question is going to be the number 1. All right, so that is that second objective, and basically what all you need to do, right? All you need to do is take one of the identities, all right, take one of the trig functions, sorry, and change it into its cofunction. Remember, there's 3 cofunctions, and then you can go back the other way with all 3. So sine and cosine are cofunctions, but you can also go back. You can say cosine and sine are cofunctions, like that. Generally, we write it like this because co, and co. So we say sine, tan, and secant have cofunctions. But remember, you may use it back the other way as well, okay? And so having used these these cofunction identities, I was able to solve all these problems that I did for you over here. The next objective of this lesson is to solve a right triangle, to solve every piece of it. Okay, so I'm going to take the last question here, number 42, and it basically tells you a value for B, the value for C, and it says find side A, angle A, and angle B. All right, so we're going to go ahead and try this, and this is called solving the triangle. All right, so when you're asked solve the triangle, that just means a triangle has 3 sides and it's got 3 angles. Find anything that's missing. All right, so understand this problem, and you've understood so much about this lesson itself, especially the direction which this lesson takes is word problems, right? Word problems that involve trigonometry. So let's go ahead and label these. B is equal to 4, so according to that diagram, that's where B is supposed to be. C is equal to 6, so I'm going to label that as a 6. And we don't know what side A is, so if you're thinking to yourself, why don't we use the Pythagorean theorem, we will do so in a moment. We don't know what angle A is, so we're going to leave it empty. We don't know what angle B is, we're going to leave that empty as well. And we don't know what side A is, so we're going to leave that empty. All right, so let's go ahead and get started with this. The first thing that I'll do is to solve for side A. I will say that I'll use the Pythagorean theorem, and in doing so, I will take 6 and square it, 4 and square it, and then subtract those 2. And when I subtract 6 squared is 36, and 4 squared is 16. So I basically end up with the root of 20, which if you wish, you can simplify that a little bit to 2 root 5. Okay, so now we know what side A is. I know that side A is 2 root 5. All right, and I'll leave that A right there so you can identify it later. Okay, now what we need to do is we need to figure out what the 2 angles are, A and B. All right, now to do that, you have many choices. I'm just going to go ahead and begin with the sine of A just because it's alphabetical. I'll find a trig ratio of A that I know both the sides for. So if you take a look at A here, the sine of A would be opposite over hypotenuse, which is essentially 2 root 5 over 6. All right, so 2 root 5 over 6. And the question is not asking us to solve for a ratio of sides. We really need to find angle A. So what we're going to do is we're going to find the sine inverse of root 5. By the way, this can be simplified to root 5 over 3. So we need to just find the sine inverse of root 5 over 3. Now, just a few things to keep track of when you're doing that. Make sure that your calculator is going to be in make sure your calculator is going to be in degrees and not in radians. I'm going to find so let me check the mode real quick. So it is in degrees. You're going to find the sine inverse of the root of 5, and you divide that by 3. And when you do that, you end up with 48.19 degrees. I would really recommend you keep everything to at least 2 decimal places. So 48.19 degrees is the value for angle A. All right? And if you think about it, you don't need to run another trig ratio for B, because if now you know that angle A is 48.19 degrees, you know that a triangle adds up to 180 degrees, and you already know that this is a right triangle. So to find B, it's a lot simpler than it looks. Simply take 180 degrees, subtract 90 degrees, subtract 48.19 degrees, and that will tell you what angle B is going to be. All right, so you're welcome to do that by yourself. Just to keep this lesson relatively short, we're going to continue to move on here. Okay. Now, the last part of this lesson, and the most challenging part of the lesson, is your ability to read a word problem and to apply trig to it and then solve it. All right, so let's go ahead and read this problem over here. It says a straight trail leads from the Alpine Hotel, so here is the hotel, elevation 8,000 feet, to a scenic overlook, elevation 11,000 feet. All right. The length of the trail is 14,100 feet, and our job is to find what is the inclination or the grade of the trail. So if you've ever been on a trail, if you are not very used to walking a lot, if you're not very used to climbing a lot, you don't go on the more steep trails. So they're saying, can you find the steepness of this trail, basically? All right. So what we're going to do here is we're going to take that 3,100 feet that we're getting and 14,100 feet. Now, if you're wondering, how did they get 3,100 exactly? Because that was not written in the question. It's because when you're told that something has an elevation of 8,000 feet, that means from sea level, right? From sea level, from ground level, call it that if you wish. Especially if it's a resort or a hotel, they're usually built on a higher ground. So the hotel is built 8,000 feet above sea level. The overlook is 11,100 feet above sea level, right? So this being 8,000 and this being 11,100, when you subtract the two, that's why we end up with a side of a triangle that's 3,100 feet. So if you think about it, this problem is essentially the same as the previous set that I was doing with you. In fact, it's a little easier because you don't need to solve the triangle. You just need to find certain things about it. So this is 14,100. This is 3,100. And our job is to find the steepness of this trail. And so we're going to go ahead and find what angle B is because they ask for it. All right. And they also ask us for the steepness, so we'll find that as well. All right. So the first thing that we'll do is we'll find the steepness. The steepness of something is basically how much, this is going to ring a bell for you, how much you rise over how much you run. Now, what does that sound like, right? How much you rise over how much you run. That's called a slope. Well, guess what? That it also has the same word, which in some textbooks, it's also called a gradient or a grade, all right? And in this book, they talk about this as an inclination. This is not often used, but there you have it, right? So how are we going to find that? If you think about it, we can use the Pythagorean theorem, and if we use the Pythagorean theorem, it will give us this this third side, and that third side represents the run, right? So we'll take 14,100 and square it, and we'll subtract 3,100 squared. And when we do that, we will have a run, right? So let's do that really quickly. So we take the square root of 14,100, like that, and so I end up with 13,754. So let's call it 13,755. Okay, so that third side is 13,755 feet. All right. So when you are asked for the grade of the trail is you take how much you rise, 3,100, and you divide it by how much you run, which is 13,755, and just divide out those two. Whatever you get when you do something like that is the answer to the inclination part of it. All right, so don't mind trying this. So 3,100 divided by what we got previously, and so you end up with 0.225. All right, so 0.225 is the answer that we get here. And generally, we don't leave things like that because that does tend to confuse people. These are usually on the sides of the road and stuff like that. So this is a very steep trail. This is a trail that's got a 22.5% grade. Okay, so as you're going sideways, you're also going up, and you're going up quite a lot. All right, so there is that first piece of the question. Now to find angle B, right? To find angle B, which is the other thing that they're asking you, to find angle B, basically pick a ratio, all right? Pick a ratio. I'm going to use the sine ratio, all right? The sine of angle B, recall angle B is right over here. So the sine of angle B is the opposite side over the hypotenuse side, all right? So 14,100, like this over here. And this time you need to find the sine inverse, right? If you look back at what we just did today, to find an angle, you have to do something like this over here. So if you find the sine inverse of really the same number that we, no, not the same number, okay, but of this ratio over here, you will have the angle B. So sine inverse of 3,100 and divided by 14,100, like this over here, and we end up with 12.7 degrees. All right, remember it's in degrees right now, so B is equal to 12.7 degrees. That is that. Okay. All right. Now we're going to try one last question, and I would argue this is perhaps the hardest question of all of the problems that we've done so far. So you want to lend an ear to this. This one is usually the one that students have struggled with in the past. First, let's understand what's going on and try to diagram it. Part of what makes this a difficult problem is they don't give us a diagram for it. Okay, even if you look in the book, there is no diagram for number 70, right? So diagramming it, so far we've had essentially all the diagrams when we needed them, but this time you don't have a diagram, so to do it all by yourself, that's usually what gets people, all right? So number 70, it says, while taking a ride in a hot air balloon in Napa Valley, Francisco, Francisco wonders how high he is. To find out, he chooses a landmark that is to the east of the balloon and measures the angle of depression to be 54 degrees. All right, so what we'll do here is we'll go ahead and mark a few things here. So let's say that the balloon is right here. Okay, that's the balloon. It says to find out, he chooses a landmark that is to the east of the balloon. Now remember, he's trying to figure out how high is the balloon. So he chooses a landmark that is to the east of the balloon. Let's make that landmark all the way over here. So this is my landmark. Okay? Now, it says that, and again, because it said east, that's why we chose something that's to the right of the balloon. It says then he measures the angle of depression to be 54 degrees. So if you don't know what an angle of depression is, that is part of the objectives of this lesson and of doing this problem right here, is an angle of depression means if you were to look straight and then you were to, from your eye level, you were to look down, that is your angle of depression. And in this situation, what they're saying is the angle of depression is 54 degrees. Okay. Now, it says a few minutes later, all right, a few minutes later, after traveling 100 feet east. Okay, so again, let's pause here. What they say that the balloon has traveled 100 feet east, first off, he's moving in that direction. He's getting closer to the landmark because the landmark was to the east of the balloon and he's moved more east. So now he's gotten closer to the landmark. So now, let's suppose, this is just to exaggerate it a little bit, let's suppose that he's at that new blue dot, right? So him being closer to that landmark is one thing, but also you got to realize that he just moved 100 feet. So this part is now going to be 100 feet, like that, all right? Okay, now what happens? It says, after moving this 100 feet east, the angle of depression to the same landmark, so he looks down again at that same landmark, and he notices that this time the angle of depression is 61 degrees. So let's go ahead and make a new line, like this over here, and this angle of depression is 61 degrees, like this, all right? So using this information, all right, that's all we have essentially. What we need to figure out is what is the height of the balloon. So we're going to go ahead and we're going to solve for what now? All right, we need to figure out, so here's the ground over here, is we can say, all right, let's take this length right here. All right, and you'll see where this is going in a moment. Let's take this length and let's make a right triangle out of it. So here is a right triangle. Now there are many things that can be said now. This being a right triangle and that 61 degrees, what that means is opposite of that 61 degrees is going to be the height, all right? And if you look at the hypotenuse, that's that length that we don't know. And if you look at the adjacent side, we also don't know that, right? So there's two things that we don't know, and I'll leave that as an x and an h, respectively, right? So here's that first ratio that we have. We have the tan of 61 degrees is equal to opposite over adjacent, so h over x. Now, let's do the same thing for 54 degrees, right? So 54 degrees, its opposite side is actually h. And its adjacent side is 100 plus that x. So I'll go ahead and write that separately. So the tan of 54 degrees is opposite, which is h, over adjacent, which is x plus 100. All right? Now we're going to go ahead and set up a system to actually solve these equations. Remember, our whole objective is to find the height of the balloon, right? We need to somehow find the height of the balloon. So what I'm going to do is I'm going to take this equation, the first equation, let's call this equation number 1, and let's call that equation number 2. I'm going to take the first equation and I'm going to solve it. I'm going to solve it for x, all right? And you'll see in a moment why I chose to solve for x. X is equal to h over the tan of 61 degrees. All right, so that's step number 1. All right. Next, what I'm going to do is I'm going to take the value for x, which I'm saying is h over tan 61 degrees, and I'm going to substitute it right there. All right, so I will substitute it into the other equation. All right, so you guys will see where this is going in just a moment. H over tan 61 degrees into equation number 2, that leads to quite something that we need to solve. All right, that's going to take us some time to solve it. But we have tan of 54 degrees is equal to h divided by h over tan 61 degrees, add 100 to it. All right, so now this looks like a beast of an equation to solve. So what's the best way to solve it? Here is one technique that I can share with you. Is what I'll do is I'll go ahead and I'll multiply this on both sides, right? So if I multiply it on both sides, here's what's going to happen. You'll have the tan of 54 degrees multiplied to h over the tan of 61 degrees added to 100, and on the right side you have an h. But what you guys will notice is we have a problem here. There's an h over here, there's an h over here, and the whole point is to find what h is, right? So there is no simple and easy way to go about it. What we're going to do is, the first thing that we'll do is we'll go ahead and we'll distribute the tan of 54 degrees into the problem. And so when we do that, we end up with h tan 54 degrees divided by tan 61 degrees, and 100 tan of 54 degrees on the left side. On the right side, you simply have an h. Now again, the whole point is to get the h's onto one side. So what I'm going to do here is I'm going to bring this guy over to the right side. I'm going to bring the h to the left side. So now you have h tan 54 degrees divided by tan 61 degrees. Now you're subtracting h over here, and this is equal to negative 100 tan 54 degrees. Okay, now this is really important. This is algebra for us. What do you do when you have two of the same variables, but you're trying to make one out of them? The answer is you factorize. Okay, so that step is very important, but then again, we have used that step many times in other contexts. So you factorize out the h, and when you do something like that, you end up with the tan of 54 degrees, tan 61 degrees. Remember, this is all going to go in a calculator. Here it becomes a minus 1. And on the right side, you have negative 100 tan of 54 degrees. Now, to solve for h, the last thing that we need to do is we need to divide on both sides by that monstrosity right there. Okay, divide by this on both sides. All right, so when you do that, what's the final answer going to look like? The final answer is going to look like h is equal to negative 100 tan 54 degrees, and that is all being divided by tan of 54 degrees, which is further divided by tan of 61 degrees, and then you subtract 1 from that. Okay, so all of this goes in a calculator. So let's take a moment and let's pull up a calculator and try typing this all into. The numerator says negative 100 tan 54. So I'll put parentheses around it, negative 100 tan 54, like this. And I'll close that parenthesis, then I'll close the parenthesis again. And it's being divided by tan of 54. Now notice how I started off with the parenthesis, all right? Tan of 54, close parenthesis, that'll close in the 54, divided by the tan of 61. Now this parenthesis will close in the 61. And then what I need to do is I need to make sure that I put tan 54 and tan 61 separately so that they're divided first. So what I got to do is I got to insert yet another parenthesis right over here. Okay, so that way, look at what's happening. It'll take the tan of 54 and it'll take the tan of 61 and divide them. And then whatever it gets from that, we want to subtract 1 and that'll be the denominator. Okay, so when I do that, I get 580.6, or approximated to 500 and, let's say, 81. I believe it was talking about feet. So 581 feet. So Francisco is that high above the ground. Okay, so let's just kind of go over really quickly what I did with this example. One of the hardest things is to set it up. But a hint I'll give you, considering how this is right triangles and a lesson on right triangles, is once you set it up, you want to make sure that you've made a right triangle out of that situation. Then after that, what I did is I had to set up a tan of both of the angles, and you will find that in the homework as well. When you have to take multiple measurements, it's called indirect measurement. When you need to do that, you'll find yourself setting up usually two tan ratios. Yes, it's possible to set up some other kinds of ratios, and you're welcome to look at this example again and be like, wait, couldn't we have done this in an easier way? We went ahead and we set up two of these ratios. And then from there on out, it's just a bunch of algebra. Okay, you have to solve one of them for x. And by the way, I promised you why we talk about, or that we talk about, which one do you solve for. Again, the reason why I solve for x here is because that way it would give me something that had height in it, because eventually I was going to go over to the other equation and have to solve for height. Yes, you could have just solved for height here, right? But then height would be eliminated, and then you'd spend the rest of your time finding x. Maybe that would have been a little bit easier. Not sure, not going to go back and redo that or anything, but there you go. That's the example that I had for you for word problems.